Welcome. Today we're diving into the fundamentals of networking. Whether you're a beginner or just looking to refresh your knowledge, understanding networking is essential in our connected world. Networks are everywhere, from your home Wi-Fi to the vast internet. But what exactly is a network? Simply put, it's a group of devices linked together to share resources and information. In this video, we'll break down the key concepts, explore how networks operate, and discuss why they're so important in daily life and business. Let's start by exploring what makes up a network and why it matters. Network is essentially a collection of computers, servers, mainframes, network devices, or other devices connected together to share data and resources. These connections can be physical, like cables, or wireless, using radio waves. Networks allow us to communicate, collaborate, and access information quickly and efficiently. Think of it as a digital highway where information travels from one point to another. Understanding this basic definition sets the stage for everything else we'll cover in this video. Networks come in various shapes and sizes, each serving different purposes. The most common types are local area networks (LANs), which connect devices in a small area like an office or home, and wide area networks (WANs), which span larger geographic areas such as cities or even countries. There are also metropolitan area networks (MANs) and personal area networks (PANs). Each type has its own unique features and use cases, and understanding these differences helps you choose the right network for your needs. Local area network, or LAN, is a network that covers a small geographic area, like a single building or a campus. LANs are commonly used in homes, schools, and offices to connect computers, printers, and other devices. They typically use Ethernet cables or Wi-Fi to link devices together. LANs are known for their high speed and reliability, making them ideal for sharing files, printers, and internet connections within a limited area. Wide area networks, or WANs, connect devices across large distances, often spanning cities, countries, or even continents. The internet itself is the largest example of a WAN. These networks use various transmission methods, including leased lines, satellite links, and public networks. WANs enable organizations to connect remote offices and users, making global communication and data sharing possible. Metropolitan Area Network, or MAN, bridges the gap between LANs and WANs. It typically covers a city or a large campus, connecting multiple LANs within a metropolitan area. MANs are often used by businesses, universities, and government agencies to link buildings and share resources efficiently. They provide high-speed connectivity over a broader area than a LAN, but are not as expansive as a WAN. Personal Area Networks, or PANs, are the smallest type of network. They connect devices within a very short range, typically a few meters. Examples include connecting your smartphone to your laptop via Bluetooth or using a wireless headset. PANs are designed for personal use, making it easy to share data and resources between your own devices quickly and conveniently. Network topology refers to the arrangement of devices and cables in a network. Common topologies include star, bus, ring, and mesh. Each topology has its own advantages and disadvantages in terms of performance, reliability, and cost. For example, a star topology connects all devices to a central hub, making it easy to manage, while a mesh topology connects every device to every other device, offering high redundancy. In a star topology, all devices are connected to a central hub or switch. This setup makes it easy to add or remove devices without affecting the rest of the network. If one device fails, the others remain connected. However, if the central hub fails, the entire network goes down. Star topology is popular in modern LANs because of its simplicity and ease of troubleshooting. Bus topology connects all devices along a single cable known as the backbone. Data travels along this cable and each device listens for data addressed to it. While bus topology is simple and cost-effective, it can become slow and unreliable as more devices are added. If the main cable fails, the entire network is affected. This topology is less common today but was widely used in early networks. In a ring topology, each device is connected to two others, forming a circular data path. Data travels in one direction around the ring until it reaches its destination. This setup can be efficient for small networks, but if one device or connection fails, it can disrupt the entire network. Ring topology is less common today but is still used in some specialized applications. Mesh topology connects every device to every other device in the network. This provides high redundancy and reliability as there are multiple paths for data to travel. If one connection fails, data can take another route. Mesh topology is often used in critical networks where uptime is essential, such as in data centers or military applications. However, it can be expensive and complex to set up. Networks rely on a variety of devices to function smoothly. Some of the most common include routers, switches, hubs, and access points. Each device plays a specific role in managing data flow, connecting devices, and ensuring security. Understanding what each device does is key to building and maintaining an efficient network. Let's take a closer look at these essential components. Routers are the traffic directors of a network. They connect different networks together, such as your home network to the internet. Routers analyze data packets and determine the best path for them to travel. They also provide security features like firewalls and can assign IP addresses to devices on the network. Without routers, devices on different networks wouldn't be able to communicate. Switches are used to connect multiple devices within the same network, such as computers, printers, and servers. They receive data from one device and forward it only to the intended recipient, making communication more efficient. Switches help reduce network congestion and improve overall performance. They are a core component of most modern LANs. Hubs are basic networking devices that connect multiple computers in a network. Unlike switches, hubs broadcast data to all devices, regardless of the intended recipient. This can lead to network congestion and security risks. Hubs are inexpensive and simple but are largely replaced by switches in modern networks due to their limitations. Access points are devices that allow wireless devices to connect to a wired network. They are commonly used in Wi-Fi networks, providing connectivity for laptops, smartphones, and tablets. Access points extend the range of a network and make it possible for users to move freely while staying connected. They play a crucial role in modern wireless networking. Network cables are the physical wires that connect devices in a wired network. The most common types are Ethernet cables such as Cat5e and Cat6. These cables transmit data quickly and reliably, making them ideal for high-speed connections. While wireless networks are popular, cables are still widely used for their stability and performance, especially in business environments. Wireless networking uses radio waves to connect devices without physical cables. Wi-Fi is the most common wireless technology, allowing laptops, smartphones, and other devices to communicate over the air. Wireless networks offer flexibility and convenience, making it easy to connect multiple devices and move around freely. However, they can be affected by interference and security risks. Every device on a network needs a unique identifier known as an IP address. IP addresses allow devices to find and communicate with each other. There are two main types, IP4, which uses a 32-bit address, and IP6, which uses a 128-bit address. As more devices connect to the internet, IP6 is becoming increasingly important to accommodate the growing number of addresses needed. Subnetting is a technique used to divide a large network into smaller, more manageable segments called subnets. This helps improve network performance and security by limiting the number of devices in each subnet. Subnetting also makes it easier to organize and manage IP addresses, especially in large organizations with many devices. MAC address is a unique identifier assigned to network interfaces for communications on the physical network segment. Unlike IP addresses, which can change, MAC addresses are hard-coded into the hardware. They play a crucial role in local network communication and help ensure that data reaches the correct device. Protocols are the rules that govern how data is transmitted across a network. They ensure that devices can communicate effectively regardless of their manufacturer or type. Some of the most important protocols include TCP/IP, HTTP, FTP, and SMTP. Each protocol serves a specific purpose, from browsing the web to sending emails. TCP/IP protocol suite is the foundation of modern networking. It consists of several protocols that work together to enable communication over the internet and other networks. TCP ensures reliable data delivery, while IP handles addressing and routing. Together, they make it possible for devices to exchange information seamlessly. HTTP, or Hypertext Transfer Protocol, is used for transferring web pages over the internet. HTTPS is a secure version of HTTP that encrypts data to protect it from eavesdroppers. These protocols are essential for browsing the web safely and securely, ensuring that your information remains private. FTP, or File Transfer Protocol, is used for transferring files between computers on a network. SMTP, or Simple Mail Transfer Protocol, is used for sending emails. These protocols make it possible to share files and communicate efficiently, forming the backbone of many online services. The OSI model is a conceptual framework that describes how data moves through a network. It consists of 7 layers, each with a specific function, from physical transmission to application-level interactions. Understanding the OSI model helps you troubleshoot network issues and design efficient systems. The physical layer is the first layer of the OSI model. It deals with the physical connection between devices, including cables, switches, and other hardware. This layer is responsible for transmitting raw data bits over the network medium, ensuring that signals are sent and received correctly. The data link layer is the second layer of the OSI model. It manages the direct connection between devices on the same network, handling error detection and correction. This layer ensures that data is transferred reliably from one device to another within the same local network segment. The network layer is the third layer of the OSI model. It is responsible for routing data between different networks and managing logical addressing, such as IP addresses. This layer ensures that data packets reach their correct destination, even if they have to travel through multiple networks. The transport layer is the fourth layer of the OSI model. It manages end-to-end communication between devices, ensuring that data is delivered reliably and in the correct order. Protocols like TCP and UDP operate at this layer, providing error checking and flow control. The session layer is the fifth layer of the OSI model. It establishes, manages, and terminates sessions between applications on different devices. This layer ensures that communication sessions are properly synchronized and maintained throughout the data exchange. The presentation layer is the sixth layer of the OSI model. It translates data between the application and network formats, handling tasks like encryption, compression, and data conversion. This layer ensures that data sent from one device can be understood by another, regardless of differences in data formats. The application layer is the seventh and topmost layer of the OSI model. It provides network services directly to end users and applications, such as email, file transfer, and web browsing. This layer enables users to interact with the network through various software applications. Network security is all about protecting data and resources from unauthorized access and threats. Common security measures include firewalls, antivirus software, and encryption. By implementing strong security practices, you can safeguard your network against hackers, malware, and other risks. Firewall is a security device or software that monitors and controls incoming and outgoing network traffic. It acts as a barrier between your network and potential threats from the internet. Firewalls can block unauthorized access, filter harmful data, and help prevent cyberattacks. Encryption is the process of converting data into a coded format to prevent unauthorized access. It ensures that even if data is intercepted, it cannot be read without the proper key. Encryption is widely used in secure communications, online banking, and protecting sensitive information. Antivirus and anti-malware software protect your network from malicious software such as viruses, worms, and trojans. These programs scan files and monitor network activity to detect and remove threats. Keeping your security software up to date is crucial for defending against new and evolving risks. Network monitoring involves tracking the performance and security of your network in real time. Tools and software can alert you to unusual activity, slowdowns, or potential security breaches. Regular monitoring helps maintain network health and quickly address any issues that arise. Troubleshooting is the process of identifying and resolving network problems. Common issues include connectivity failures, slow speeds, and hardware malfunctions. Effective troubleshooting involves checking cables, devices, configurations, and using diagnostic tools to pinpoint the cause of the problem. Some of the most common network issues include dropped connections, slow speeds, and IP address conflicts. These problems can be caused by faulty hardware, misconfigured settings, or interference. Understanding the root causes helps you resolve issues quickly and keep your network running smoothly. Regular maintenance is essential for keeping your network healthy and secure. This includes updating software, replacing faulty hardware, and reviewing security settings. Scheduled maintenance helps prevent problems before they occur and ensures your network remains reliable. Networking technology is constantly evolving. Emerging trends include faster wireless standards, increased use of cloud computing, and the growth of the Internet of Things, IoT. Staying informed about these trends helps you prepare for the future and take advantage of new opportunities. Cloud networking uses internet-based resources to manage and deliver network services. This approach offers flexibility, scalability, and cost savings compared to traditional networks. Cloud networking is becoming increasingly popular for businesses of all sizes, enabling remote work and global collaboration. We've covered the essential fundamentals of networking, from basic concepts and types of networks to devices, protocols, and security. Networking is the backbone of modern communication, enabling us to connect, share, and collaborate like never before. By understanding these fundamentals, you're better equipped to build, maintain, and secure your own networks. Thanks for watching, and keep exploring the world of networking.